In this video, we're going to talk about something called selective precipitation. So this is a question that is asked specifically for Ksp. Now what it gives you here, the information it gives you is a concentration of one ion, a concentration of a second ion, and it tells you that something that's in common with both of these is poured into the solution. So we have PbI2 versus CuI. And it gives us two different Ksp values. Here's the big question. When they give you two different things and they ask which will precipitate first, this is when you use the selective precipitation approach. So how you work this problem is you're going to solve for what's common in between these things. So you have CuI and you have PbI2. So the thing that is common between both of those solids is the I minus. Because I minus is what is in common between those, I can compare those values. So let's figure out how to start this. Well, first, I'm going to write my reaction for both of these things. So starting with PbI2, we have PbI2 solid breaking into its ions, so it's going to be Pb2 plus 2I minus. So that's my reaction for this thing here. Now let's write the reaction for CuI. So we have CuI solid breaking into its ions, which would be Cu plus I minus. Now that we know these expressions, let's write our Ksp expression for both. So for this first one, Ksp is equal to concentration Pb2 plus times I minus squared. And for this one, Ksp is equal to Cu times I minus. So I have my reactions, step 1, and I have my Ksp expressions, step 2. The next thing that I'm going to do is solve for the common ion. So the common ion is this I and this I. So I'm going to solve for it for both of those. So I'm going to plug in the information that I have. So I know that Pb2 plus is 2 times 10 to the negative 3. So I'm going to plug that in here. 2 times 10 to the negative 3. And where I got that is right here. I minus, I want to solve for. Ksp was also given to me. It was 1.4 times 10 to the negative 8. And when I solve for I minus for this one, I get 2.6 times 10 to the negative 3rd. Now let's explain what that answer means, okay? This means that if I add 2.6 times 10 to the negative 3rd molar to this particular situation, I will then have what you call a saturated solution. Because saturated means at equilibrium. And if I'm plugging in these values, then I have to assume that that is at equilibrium. So since this is a saturated sample, if I put in any more than 2.6 times 10 to the negative 3rd molar for my concentration for I, that will then become supersaturated. And we learn from K versus Q that supersaturated means a precipitate will form. So this is like the threshold. This is the maximum amount of the I minus that this particular situation can hold before it forms a precipitate. Now let's solve for the I minus here. Okay, so Ksp, I'm going to plug in its value, 5.3 times 10 to the negative 12. Cu plus is equal to 1 times 10 to the negative 4. And I'm going to solve for my I minus. Okay, be careful. This I minus, I had to end up taking the square root to get its final answer. This one I don't. So make sure you pay attention to coefficients and that you're raising it to an exponent. So when I solve for the I minus here, I end up getting 5.3 times 10 to the negative 8th molar. So again, let's explain what this information means. This means this is the amount of I minus in molarity that I need to add in order to make this here saturated. Now, saturated is the threshold. If I put a pinch more than 5.3 times 10 to the negative 8th, then that means that this stuff will precipitate because it's going to be supersaturated. If I put a pinch more than 2.6 times 10 to the negative 3rd in here, then that means that a precipitate will form, which will cause a supersaturated solution, which of course makes the precipitate form. So now that I know my I's, so that's step 3, you solve for what's common between these two reactions. I then compare these values, and whichever value is smallest, that will be the thing that precipitates first. Because what this is telling me is that over here, I got to add 5.3 times 10 to the negative 8th to get to where it's forming a precipitate. Over here, I have to add 2.6 times 10 to the negative 3rd to get it to start forming a precipitate. So which do I have to add less of? Well, that would be this CUI. And because I have to add less CUI, or the I minus I should say, then that means that that one will be the one to precipitate first. So when they ask what will precipitate first, step 1, write my reactions for both. Step 2, write my Ksp expressions for both. Step 3, solve for what is common between these two and compare those values. The smaller value is going to be the stuff that precipitates first because I have to add less of it to get it to be saturated. Anything in excess of this quantity here will cause a precipitate to form. So CUI will precipitate first. This is my justification because the I concentration is less than the I concentration for the PBI2. And when it says specify the concentration necessary to begin precipitation, it would be any quantity greater than this value here. So they ask this specifically for Ksp. It's usually like a 1-point question towards the end of a free response. They like to ask the K versus Q question a little bit more often than this particular question, but it's definitely one that they ask, so you need to be able to answer it. So I hope this was helpful, and I believe that this is it for Ksp.